Hello. In this video, we'll use helical sweep, which we just learned, to make a bolt. A bolt has threads on it, which are helical in nature. So we'll use the helical sweep for making those threads. There are some specifications provided over here about the size of the threads and the pitch of the threads, and we'll follow those specifications and make a bolt of this sort. So let's get started. I'll keep this on the side and refer to it as a checklist. I'll start a new project. I'll call this bolt. I'll make sure that I have the right system of units because the specifications are in mm. I'll change the system of units to mm. Model properties, not over here. Units. Okay, so now we should be in mm, and the first thing that we'll do is that we'll make the shank, that's the cylindrical portion of a bolt, which should have a major diameter of 6 mm and a length of 30 mm as prescribed over here. Okay, so that would be a simple extrude. Make a circle equal to the major diameter, which is 30 mm. Not 30 mm. The major diameter is 6 mm. Sorry. If you are within extrude and you want to modify the sketch, you can go to placement and edit the sketch from here rather than going out and then selecting sketch from here and editing it. So this should be 6 mm and the length of the extrude should be 30 mm. Major diameter 6, length of the shank 30 mm. And we've been told that the head has to be a hexagon, so it's a hex head. So we'll make a hexagon over here, again using extrude. And to make a hexagon, you can either use the line chain command, but that would be very complicated. So the smarter way to do it is to use this palette command over here, which has some standard shapes already made for you, and you can select the standard shape that you want. We want a hexagon, so I'll select and drag a hexagon over here. I'll put it somewhere over here. Close the palette tab from here and place this in the center. So I'll change the distance from the horizontal and the vertical central axis to 0. Over here, that's along this line, but the distance from the center to this is not being shown. So I'll ask Creo to show it to me using the dimension command, and then I'll turn it to 0. So now the hexagon is in the center. And what we have been given is the distance W, which is this distance over here between two parallel faces. We've been told that that has to be 15 mm. So we'll select two parallel faces while holding down control, and after having selected dimension, press the center mouse button and it will show us this dimension. These dimensions are over prescribed because when you make a hexagon using the palette command, it fixes the length of each segment, and both of these are indirectly conveying the same information. You can calculate the length corresponding to that that distance between two parallel faces and enter that over here, or you could just directly enter the distance, and that's what we want to do. So for that, we will select this dimension, which is this one over here. I can see that this is 0.98, and delete that from here. So now that dimension is no longer being prescribed, and I have the freedom to adjust this distance between parallel faces, and I'll change that to 15 as I've been told to do over here. Now it's making an extrusion. We want the extrusion to be on the other side because we want the length of the shank to be 30 mm, so we don't want the head to cut into that. And the height of the head, capital H, has been provided to us as 5 mm. So the depth of this extrusion is going to be 5 mm. And now we have the base bolt that we'll refine to make a proper bolt with threads and everything. If you look at the bolt over here, you'll see that the tip of the bolt is slightly tapered, and that's done by design to make it easier for bolts to be inserted. So at this stage, we'll chamfer the tip, this edge over here, using the chamfer command within model, and that looks reasonable to me. Since you're not given any hard requirements, you can be flexible. That generally looks reasonable to me. It looks close to what I've seen on actual bolts, so I'll go with that. And next, we will start making the helical profile, and there are some rough steps listed over here as well. So we've made the shank, we've made the bolt head, we've chamfered the tip, and now let's make the helical profile. For that, I'll select this plane, and I'll start a new sketch. So this sketch would be the profile, as the word profile is used for helical sweep, which would define the starting and the ending point of my helix, which will be formed. So I'll start this somewhere over here, and I'll have it end along this line. It's not snapping, which is slightly annoying. So what I'll do is that I'll make a construction line, which is horizontal, and I've made a construction line by enabling the construction mode, and now I'll make a straight line along the length of the shank. And we've been told in the requirements that even though the length of the shank is 30 mm, we want the threaded portion to be only 20 mm. So our profile should be 20 mm long. So if we do everything right, our threads should start over here and should end over here. So that's my profile, and now I'll make a center line. I don't really need to, because there is an axis that exists for the cylindrical shank that we made, but just to be consistent with how we've used helical sweep previously, I'll make a center line passing through the center of the bolt, which will be the center of the helix once we create the helix. I've made this sketch. I'll call, you should do better than I am at naming your entries in the model tree. I'll call this my helix profile. And now we'll start a helical sweep. You can select this beforehand to save yourself some time. And then when you select helical sweep, the profile has been selected as the line that you made over here, and the central axis has been selected as the internal center line that you made. You could start from this end or this end. Doesn't matter for this project. And now we need to make a sketch. For your submission, you have to make the sketch such that the minor diameter is 4.77 mm, and the profile of that thread should be an equilateral triangle. I'm not going to be very thorough for this demonstration, but that's a challenge that I'll leave you to explore at your leisure. So I'll start making the cross section of the thread, and you can make thread by adding material, but I think the more simple way is to make the base cylinder, the base shank, and then remove material from it. In that way, the diameter of your shank is equal to the major diameter, instead of you making the shank equal to the minor diameter and then adding threads on it. We are removing threads from it, which is incidentally similar to how you actually make threads on a cylindrical feature using a die, which we saw in the class. A die has cutting thread cutting teeth on its inside, and you run it on a cylindrical member. It removes material, and the major diameter would be the same as the original diameter of the feature, and the minor diameter is determined by the profile of the threads on that die. So what we'll do is that we'll make an equilateral triangle somewhere over here. I'm not being very particular over here, but what I will do is that I'll fix this angle as being 45 degrees, and let's make this length 0.65, and I'll make a second segment which would be of the same length. Should not have been 45. 180 divided by 3, that should have been 60. 60 divided by 2, that should have been 30 degrees. So let's fix that. So this should be 60 divided by 2. Rookie mistake. And now when I connect these two edges, we should have an equilateral triangle. This is the profile of my tooth. In your case, you have to be vigilant that the depth of the tooth should be such that the minor diameter, the root diameter, is equal to 4.77 mm. I'll click OK, and now this triangular cross section is being swept about the central axis along this profile. You can't see most of it because it's being swept within the cylinder which already exists, but if we remove material, you can see that it removes material from the cylinder and gives you threads. This is what we need, but just to make the bolt look more realistic, we might have to go back and modify the profile of the thread. But before we do that, let's fix the pitch, which has been given to us as 1 mm. Currently, the pitch is 2 mm. So the distance between two successive threads is 2 mm. We'll half that, and that actually looks all right for demonstrative purposes over here. We'll click OK, and in this way, you have successfully made threads on your bolt. You have to do a few more things for your submission. You have to make this face over here. That should be a simple extrude. You can do that, and you need to make this round over here. I won't make that face, but I will round this edge just because it's easy to do. And lastly, you need to cut out material from your edges at an angle of 30 degrees, which has been prescribed in the requirements, and then you will have your final bolt. So for that, I'll select one of these planes. I'll select this plane, which is cutting through the two vertices of my hexagon, and I'll do a revolve cut. So select revolve, and I'll make a line over here which should be at a 30-degree angle to this face of the bolt head. So this should be the way it's showing me, 180 minus 30, 150 degree, and this remaining angle is 30 degree, which is the same as this angle. And then I'll just make a closed figure, because that is something that you need for revolve and all of these sweeping operations. I'll make a center line over here, And then this cross section which I made would be revolved about this center line, and that's what happens. But I want it to be removing material, so I'll enable remove material. It removes material from our part. If you were very proper, then what you should have done is that you should have made this profile such that the material is such that this material which is removed forms a circle that is tangent to this and let's see if we can improve this. So let's enable hidden lines, and reduce and move this point somewhere else. So what we can do is that we can add a dimension over here, and we can increase this distance. That's better, but not exactly what we need. That's good enough. Let's try to improve it slightly. So 7.4, and that's going to be the last try. Okay, that's good enough. So in this way, you've created a bolt. You can go to View, change its appearances. I've given it a steel finish, and then you can select different scenes from here. And then when you select shading with reflections, it gives you a somewhat of a realistic rendering. You can hide all of these datums and uh, background features and take a picture, which you'll have to submit for your assignment. Hope this video made sense. Thank you for watching.